So what are we doing tonight? How'd you do on your SAT test?
I felt it was really easy.
Compared to the problems we were practicing on?
Oh yeah, it was. Yeah, compared to the problems we were practicing on, even like before we got the ones off the SAT site, it was incredibly easy.
Wow. I wonder what that means. Now I don't know what to do because I'm not a big believer in practicing super difficult problems when you're trying to tutor somebody for the SAT. I'm more of a believer in you spend your time on the medium difficulty problems. Now I'm not sure. Okay, I'll have to ask others. I got 3 or 4 students that took that test last week. So
they haven't told us when we're getting our scores yet either.
Well, that's true. Yeah. So what are they working on this week? What have they?
We're working on trig functions and arcs and
okay.
Like using radians and circles and stuff like that.
Okay. Do you have any specific problems?
Yeah, I'm sending them to you right now. Picture quality is not great, but we'll have to do.
Probably doesn't need to be.
Or just because my camera is really screwy.
Tell me when it's been sent.
Sending right now.
Most important thing to know for trig is this.
SOHCAHTOA.
Yeah. And I mean that is the most important.
It's sent.
You should know that backwards and forwards.
Mm-hmm. Sine is opposite of our hypotenuse. Cosine is adjacent of our hypotenuse. Tangent is opposite of the adjacent.
Which one of these should I open first? The right?
Either way.
I'm sorry, what?
Either way.
I'll go left to right then. All right. This is one skill you absolutely have to know how to do, which is to do all of the angles inside the unit circle that are multiples of 30, 45, and 60. Like
we've been learning to memorize that.
Like 300, like 225, anything like that, okay? And it all begins if you can memorize the first quadrant angles, then I can show you how to convert any angle that's not in the first quadrant to a first quadrant angle so that you know how to do it. The secret is to memorize the first quadrant angles. And these are the only 2 triangles you need to know.
Mm-hmm.
As you can tell, these are the same 2 triangles I've been working with you for 3 years. Now, tell me what the sine of 30 degrees is.
Sine of 30 degrees is root 3 over 3.
No. Opposite over hypotenuse.
Oh, it's one half, sorry.
That's all right.
Yeah,
tell me what the tangent of 30 degrees is.
That'd be root 3 over 3.
Okay. So your teacher wants you to rationalize it?
Yeah.
Because this actually came out to be 1 over root 3. And
yeah, he told us to rationalize them.
Yeah, that's too bad. Most intelligent thing I've heard in the last 5 years is the trig teacher that told his students not to rationalize stuff. And the reason is, what's cotangent of 30 degrees?
Root 3.
Ah, see, it's much easier if you haven't rationalized it. because if I've rationalized it, I get root 3 over 3, and now the cotangent is 3 over root 3, and it needs to be rationalized again.
Mm-hmm.
Well, you still get the same answer as always. You get root 3. But when you rationalize, sometimes it makes it harder to figure out what the reciprocal function is. But that's okay. I'll go with whatever your teacher wants. If he wants you to rationalize everything, then rationalize everything. What is the sine of 45?
Sine of 45 is root 2 over 2.
What's the tangent of 45?
1.
Perfect. So you know all your first quadrant angles.
Yeah.
Okay. Now let's figure out how to do angles that are not in the first quadrant. Okay, that's 90. I'm going to work in degrees until we get going, and then I'll switch. Let's take an angle that is 135. What's the sine of 135?
You'd find the corresponding angle that's closest to the x-axis.
That's called the reference angle.
Reference angle,
In other words, you're going to find that angle theta, but theta is always 180 degrees minus whatever angle you're looking at.
Mm-hmm.
In other words, that theta is not the same as what I drew there. In other words, theta is 135.
So it'd be 45.
Right. So that angle is 45, and the way you do trig functions is that's the same numerical value as the sine of 45 or the tangent of 45. The only thing that's different is the plus or minus sign. So let's go through it. What is the sine of 135?
Root 2 over 2.
Plus or minus?
It would be positive because the sine's positive.
Correct. What's cosine of 135?
It'd be negative root 2 over 2.
Yeah, sounds like you're pretty good on your unit circle. What's the tangent of 210?
210?
Huh? What's its reference angle?
That'd be 30.
Okay. So let's put that in parentheses. That's kind of the way I always like to do it. Because
no, I just got confused because you said the number.
Well, you have to find just the numerical value of tangent of 30 degrees. What is that?
Tangent of 30, that'd be root 3 over 3.
And now what's its plus or minus sign being in the third quadrant? What is it?
Oh, in the third quadrant, it'd be positive.
Correct. And we're looking at 210, not 30. In other words, to figure out what quadrant it's in, you always have to look at the original angle. All right, well, it looks like you know this unit circle pretty good. Let's do your problems. I didn't realize you were going to know it so well. That's excellent. All right. Where's the ray go? What quadrant?
Ray?
Well, this is a negative angle.
Oh, okay. It's going to go in...
Negative angles always get measured clockwise, not counterclockwise. Where's it going to end up?
It's going to get measured in quadrant 3.
Quadrant 2.
2? 25?
180 degrees to get from the x-axis to the other x-axis, right?
Yeah.
In other words, every quadrant is 90 degrees. So if I'm going 225, I got to go 180 plus 45.
Mm-hmm.
So there's my angle. Now, the way to solve the problem is, what is the equivalent first quadrant angle?
The reference angle is 45 degrees.
Yeah, that's what I meant, the reference angle. And so let's just come up with the number, and then we'll figure out what quadrants it's in. I always do the plus or minus sign last.
It's √2/2, and since it's in the quadrant 2, it'd be a negative √2/2.
Perfect. That's the way to do it. That's the proper sequence to do it in. Now, tangent of minus 120. Quadrant's that in?
That's going to be 3, because it doesn't fully go 180.
Right. In other words, it's minus 120. So what's the reference angle?
60 degrees.
It's the tangent of 60.
Tangent would be √3.
Plus or minus?
It would be minus.
All,
oh, no, it's plus because you're in the tangent.
all students take calculus.
Okay, yeah, sorry for that.
That's the best way to do it. I mean,
Yeah.
there are various ways to figure out the sine. The other way is you draw a triangle, and the x-coordinate is negative and the y-coordinate is negative. Since the tangent is the y-coordinate over the x-coordinate, it's positive. But the easiest thing to do is just remember all students take calculus. That never goes wrong. Okay? Now, tangent of 11 pi over 6. Have you gotten to the point yet where you can think in radians, or are you more comfortable converting everything to degrees?
Somewhat. I know where 11 pi over 6 is. It's
work in radians. The sooner you can get there, the better.
Yep. So you'd go completely around, except you go to the 30 degrees before 2 pi.
Good. So the reference angle is 30 degrees, right?
Mm-hmm.
Okay. What's the tangent of 30 degrees?
√3/3.
What's its plus or minus sign?
It's going to be negative.
Good. You're good at these. Have we worked on the unit circle? I don't think we have.
No, we've only just done it just a little bit in class. It's just fairly simple.
Well, normally, every student I ever talk to is terrible on the unit circle until I work with them for about an hour and give them my Unit Circle 101 lecture, and then they tend to figure it out. But
as long as I know, I can think of where the fourths are, and then I can think of where the sixths are.
Okay.
And rationalize them down where you can with the fraction.
What's this reference
angle? That's going to be referencing 135. So reference angle is going to be 45 degrees.
What's the cosine of 45?
Cosine of 45 is √2/2.
And what's its plus or minus sign in this quadrant?
Negative. Negative.
Good. Excuse me. Sine of minus 5 pi over 6. It's actually two ways to do this problem. Well, let's talk about it. Since you're so good at the other way, you don't really need my help on the other way. But there is a property of trig functions that's worth knowing. And that is the sine of a negative angle is equal to minus the sine of the positive angle. Same thing with tangent. Tangent of a negative angle equals minus tangent of the positive angle. That's because both of those are odd functions. Cosine is an even function. And if you'll remember right, with even functions, the cosine of negative x equals the cosine of positive x. So you want to memorize these three. You want to know that sine and tangent are both odd. Therefore, it's sometimes the easiest thing you can do with a negative angle is to use this principle and turn it into a positive angle. You with me?
Yeah.
Oh, let's do that here because it does make it marginally easier. In other words, this is the same as minus the sine of 5 pi over 6. What's the reference angle? If I'm looking at just this, what's
30 degrees.
Okay, what's sine of 30 degrees?
1/2. Okay.
And what quadrant is it in? So what's its plus or minus sign?
It's in quadrant 3, so it's negative.
Actually in quadrant 2. No,
But it's a negative.
Ah, see, well here's where I confused you. 5 pi over 6 is in quadrant 2. That makes the sign positive, and then I carry forth that negative sign, so I get that answer.
Okay.
You did it the more traditional way, which would be to draw the thing, and it's in quadrant 3. In other words, your angle is like that, right? And that's 30 degrees. So you still have the same reference angle, so you still come up with 1/2, and then you know you're in the third quadrant, so you put a negative sign on it. So you get the same answer, as you should.
Yeah.
It's just we did it slightly different techniques.
Okay.
And I have no problem with the way you did it. That's fine. I was just trying to teach you an additional property of these trig functions.
No, you're good. That makes sense. I just didn't catch it there. I was just like,
Well,
wait.
and notice that if you do it this first way, then you're really trying to figure out the sine of 5 pi over 6, which is positive 1/2. But then you got that negative sign in front there, so that's what turns it
So you
negative.
just carry them.
Yeah. Either way, you get negative 1/2. And it just kind of depends on how you look at it. There are going to be times where it's very advantageous to use this property. This isn't necessarily one of them. I pointed it out just to point it out. Doing it the way you did it is perfectly satisfactory. Got the cosine of 7 pi over 6. What's its equivalent? What's the reference angle?
60 degrees.
Let's talk about this. You don't need much help here, but this might help you. Notice what is in common with all of these things. Those two numbers multiply to 180. So if you're converting radians to degrees, this is the best way to do it. Forget that conversion factor they give you. That's the hard way to do it. I can do this in my head every time. If I've got to use the conversion factor, pi over 180 or 180 over pi, I got to write it down and do it on paper. Okay? Now, the beauty of this is, what's 2 pi over 3? If
2 pi over 3.
Yeah, pi over 3 is 60. What's 2 pi over 3?
120.
If pi over 6 is 30, what's 7 pi over 6?
210.
Now, to me, that's a much easier way to convert radians to degrees. You only have to know one thing, that the denominator times the angle is equal to 180. And then all of these hard ones, like 2 pi over 3 or 7 pi over 6 or 11 pi over 6 would just be 11 times 30. So to me, this is the easiest way to convert radians to degrees. Yeah. Like I said, you don't seem to have much problem with it, so I'm not going to focus a lot on that, but I did want to point it out. You did get this one wrong. Cosine of 7 pi over 6. What's the reference angle?
Wouldn't that be 60 degrees?
Subtract pi. That's what you want to do. In other words, this is actually pi minus theta, theta minus pi, 2 pi minus theta. In other words, that's the same as 180 minus theta, theta minus 180, or 360 minus theta. So recognize that you're in the third quadrant. So in the third quadrant, do that one right there. 7 pi over 6 minus pi is what?
I'm confused.
Okay, here. 7 pi over 6 minus pi. We're getting that from that right there. That's the formula we use whenever we're in the third quadrant, is we take our angle and we subtract pi from it. That gives us the reference.
10 minus pi.
Well, pi is 6 pi over 6, so that's pi over 6, which is 30 degrees, not 60. Tell me if you're confused, where I need to clear it up.
I'm just looking at a blank circle here. It's on the sheet of paper, and that just doesn't make sense to me.
Okay, 7 pi over 6 is what angle?
That's 210.
Okay. What's the reference angle for 210?
The reference angle for 210 is 60 degrees.
No, it isn't. It's 30. It's theta minus 180. In other words, if I draw the 210 degree angle, goes to 180, then it goes 30 degrees further. That's 30 degrees, right?
So if the reference angle is the angle that goes past that, oh yeah, you're right, it is 30, it is 30, it is 30, because it goes to the x, it goes to the x, it's 30.
The reference angle is always the angle that the ray makes with the x-axis.
Yep, okay.
That's the reference angle.
Okay.
And these formulas give you the reference angle. 180, if you're in degrees, it's 180 minus theta. If you're in radians, it's pi minus theta. And in the third quadrant, it's theta minus 180 if you're in degrees, or theta minus pi if you're in radians. And we were in the third degree, so it's 7 pi over 6 minus pi, which is pi over 6, which is 30 degrees.
Okay.
What's cosine of 30 degrees?
Cosine of 30 degrees is Sorry.
It's all right. You're quicker than anybody else with these, so I'm not going to...
1/2.
No, it's root 3 over 2.
Root 3 root, okay.
No, that it's either root 3 over 2, 1/2, or root 2.
That's the long side.
Those are the three answers. Root 3 over 2, 1/2, or root 3 over 3. Okay. The thing that you always want to memorize, that you want to know instantly, is the sine of 30 degrees is 1/2. That gets you a long ways, because that prevents you from saying that the cosine of 30 degrees is 1/2. You know, it can't be. The cosine of 30 degrees can't be the same as the sine of 30 degrees, although it is for 45 degrees, but not 30. Okay, which means this can't be 1/2. It's got to be the other answer, which is root 3 over 2. We're in the third quadrant. What is its plus or minus sign?
Minus 10.
There's the cosine of 7 pi over 6. All right, Cole, you're in pretty good shape on trig. I'm impressed. Yeah. Yeah. No, that's a good thing to know, too. You're just a junior. What are you taking next year?
I'm taking stats, maybe stats.
Don't like hearing that. I'd rather you take pre-calc trig. And here's one reason I'll tell you that. I don't tutor stats, just so you know.
Okay.
Okay? I tutor everything else. The only subject I do not tutor is stats and probability. I mean, I'll do a little bit of tutoring on both, you know, during the course of an algebra class. But if somebody's taken a stats class, I do not know that much stats to help them.
All right. I don't know if I can change it at this point. I don't know.
Well, just know that I don't tutor stats, and I do tutor pre-calc and trig. So I'm gonna guess that you would do a lot better on pre-calc and trig in terms of grade point, with or without my help. Even without my help, I think you'd do better on trig. I can see right now how good you are at trig. So if you can change it to pre-calc trig, you should. Plus, trig and pre-calc are going to be more valuable to you in college than stats. There's nothing wrong with stats. That's a fine discipline. But college administrators are looking for kids that know calculus or pre-calculus even, especially with your math skills. I mean, I don't know what you plan on majoring in college, but I hope it's a STEM class, because you got good math skills.
Psychology.
What's that, Cole?
I was thinking psychology.
Well, that's okay also. I don't know if you'll ever have to take calculus for psychology, but that's almost a STEM subject.
Yeah.
Not everybody would say that, but I'm saying it. I almost went to graduate school in psychology, even after getting an engineering degree. I'm
thinking going to grad school for either clinical, so like therapy, or criminal psychology.
Uh-huh. Yeah, I actually applied to CSU grad school to get into their psychology program, but it never happened. So.
Yeah, CSU is the only one that has well, one of the only schools in the country that has psychology as a bachelor's of science, not a bachelor of liberal arts.
Interesting, very interesting. Yeah, that's why I said it's almost a STEM subject.
Mm-hmm.
So
I'm definitely going to have to take like complicated math and science, because I know I have to take chem and stuff like that for the psych degree.
All right. Cole, let's see. What schedule are we on now? Are we going to be on now? Are we going to be doing 6s or 3:30s?
I think 6s. I don't know about Monday because we have a full run for the play on Monday.
Well, let me make sure
I'll let you know.
sixes are open because, yeah, I can move you to 6 next Monday. You want me to?
Yeah, sure. Let's just do that for now,
And the following week, don't change it yet?
following week you can bring it back to 4 or 3, 4 or
3:30.
3:30 either way.
3:30, okay. I'll leave it where it was, which was 3:30.
Mm-hmm.
All right. I will talk to you at 6 next Monday.
All right, sounds good.
All right, Cole. Bye-bye.